Okay, let's dive right into this. Mastering ports for peripheral connection, we're talking specifically about USB, HDMI, and VGA, is literally the ultimate challenge for Cambridge computer science success. Seriously, whether you're tackling syllabus codes 0417, 0478, 0983, 0984, 2210, or our main target for this explainer, AS and A-Level 9618, this topic is an absolute beast. It appears in every single examination series, no exceptions. But I want you to think of your exam strategy kind of like casting a magic spell. Stick with me here. Magic spells are essentially just really specific structural frameworks. If you cast the exact right spell, boom, you unlock maximum marks. But if you fumble the incantation, it completely falls flat. So today, we're going to make sure your structural frameworks are absolutely bulletproof. So here's the million-dollar question. Why do students constantly struggle to apply these port concepts to unfamiliar contexts? I want you to imagine two students taking the exact same past paper. Let's call them Alex and Sam. Now, Alex overloads their answer with raw, technical computer science facts about USBs, but provides absolutely zero analytical depth. It's just a brain dump. On the flip side, we have Sam. Sam rushes through the paper, panics, and completely misses the command word requirements for an HDMI question. Both of them fail to secure those top marks, even though they technically know the specifications. Why? Because their structural framework is flawed. Cambridge examiners aren't just looking to see if you can blindly memorize the pin layout of a VGA cable or the transfer speeds of a USB Type-C. They are actively hunting for your ability to take those rigid technical concepts and mold them into whatever crazy, unfamiliar scenario they've cooked up in the exam prompt. Just regurgitating textbook definitions without applying them to the specific case study, that earns exactly 0 application marks.
All right, here is our roadmap for today's session. We're building a comprehensive, super organized pathway from basic theory straight through to high-value examiner insights. First up, we'll cover the core principles of ports. Next, we dive into the procedural framework. Third, we'll tackle critical analysis and evaluation. And finally, we will wrap up with the absolute most important part: top examiner warnings. Let's get to work.
Section 1, Core Principles of Ports. It is time to go way beyond memorization.
There is a massive, clear divide between average students and the top performers. On side 1, we have the rote memorization of facts. This is our buddy Alex from earlier. But on side 2, we have connected, conceptual understanding that is completely transferable to unfamiliar contexts. Top-performing students don't just list facts, they build a conceptual web. But how do you actually structure this web on exam paper? We use the Peel framework: point, evidence, explanation, link. When you're looking at assessment objectives specific to computer science, the Peel framework is your absolute best friend. For example, if you make a point about HDMI transmitting digital audio and video, your evidence is the underlying protocol. Your explanation details how this prevents signal degradation when compared to something older like VGA. And finally, your link ties it all directly back to the specific user scenario given in the question. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, the procedural framework. This is all about algorithmic thinking in action.
Okay, this is where we start transforming those red pen marks into green check marks. Our core weapon here is what I call the method mark strategy. Listen, in the Cambridge syllabus, marks are heavily awarded for the process, not just the final answer. Step-by-step decomposition and algorithmic thinking are where the bulk of your marks are actually earned. When you're faced with a complex evaluation question, please do not just write a massive, intimidating paragraph of unformatted text. Examiners hate that. Instead, use a step-by-step approach to climb toward the correct solution systematically. Let's say you're asked about USB polling. First step, define the polling process. Second step, explain the interrupt mechanism. Third step, state the exact benefit to the CPU. By breaking your answer down algorithmically, you are literally handing the examiner the method marks on a silver platter, letting them tick them off one by one.
Let's codify this success blueprint. Here is the rigorous 5-step exam strategy protocol you need to systematically tackle and completely break down any exam question on peripheral ports. Step 1. Deconstruct the question. What exactly is the command word? What's the context? Step 2. Extract relevant data. Are they asking about serial or parallel transmission? Is it a short distance or long distance requirement? Step 3. Select your analytical framework. Are you using Peel? Is it a comparative structure? Step 4.
Execute with clear notation. Write your steps sequentially. And step 5, present with correct terminology. Don't just write something simple like, the wire sends data fast. No, you need to say, the interface supports high-bandwidth serial transmission. Following this protocol ensures that even when you face the absolute hardest, multi-layered question, you have a solid structural framework ready to deploy. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IJCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IJCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, drilling deeper into procedural execution, let's talk about essential data interpretation skills. This is where we run a little interactive workshop. When dealing with peripheral ports, examiners love to throw raw data at you. Imagine a complex data table on your screen right now. First, you might need to extract data directly from binary representations, like decoding a USB data packet. Then, you might need to perform required calculations, say, determining the time it takes to transmit a massive file over a USB 2.0 connection versus a USB 3.0 connection, given their respective bandwidths. And finally, the most crucial part, you must draw evidence-based conclusions from that data. For instance, you'd conclude why HDMI is vastly superior for a home cinema setup compared to VGA based purely on the calculated data bandwidth and digital signal properties you just worked out. Moving smoothly from raw binary extraction to hard, evidence-based conclusions is exactly what separates the novices from the absolute masters.
Welcome to Section 3, Critical Analysis and Evaluation. It's time to start thinking like an examiner.
When a question pushes into high-level evaluation, and believe me, in Syllabus 9618, it absolutely will, you have to evaluate the quality of the communication protocols or data handling algorithms. You need to consider time complexity. When a peripheral device connects via USB, how does that interrupt handling algorithm impact the CPU's time complexity? What about the space complexity involved in buffering incoming HDMI video frames? Then you've got to think about the edge cases. This is huge. What exactly happens if that cable is disconnected right in the middle of a transfer, or if a corrupted packet is received? Finally, what is the overall effect on system performance? Analyzing these specific elements is exactly what examiners are desperately looking for in top-tier answers.
To nail that evaluation, we use the Deconstruct, Solve, Evaluate framework. Step 1. Identify given information and break it down into logical steps. Step 2. Solve it systematically. Step 3. Check for reasonableness and make justified recommendations. Let's do a Find the Flaw challenge right now. Listen to this sample paragraph. VGA is better than HDMI because it is an older technology that works with more legacy monitors and therefore transmits data faster because there's less digital overhead. Okay, did you spot the flaw? It's that massive logical leap at the very end. While it's true VGA works with legacy monitors, claiming it transmits data faster due to less digital overhead is factually incorrect and absolutely not a justified recommendation. The examiner's commentary here would be brutal. They would dock marks instantly for a complete lack of technical reasonableness.
Now let's talk about comparative analysis. True comparative analysis requires exploring both similarities and differences. It is never enough to just say how two ports are different. You must use comparative connectives like whereas, conversely, or similarly, and you have to support every single point with evidence. Imagine we have 30 seconds for some speed writing. Here is how a perfect, full-mark comparative Peel paragraph sounds. Point. Both USB and HDMI are capable of transmitting digital data, but they are optimized for entirely different primary use cases. Evidence. HDMI is designed specifically for high-bandwidth audio-visual streams, whereas USB is a generalized serial bus for varied peripherals. Explanation. This means HDMI utilizes specialized TMDS channels to prevent visual degradation, while USB relies on packet-based polling or interrupts. Link. Therefore, for the video production scenario given in the prompt, HDMI is the mandatory choice for the monitor connection. Boom. That is how you secure top marks using structural frameworks.
Finally, Section 4, Top Examiner Warnings. Let's talk about avoiding the traps.
So what are the traps? Here are the top 3 student mistakes that consistently cause candidates to hemorrhage marks on peripheral port questions. First, using the wrong formula or algorithm for the specific context. This is like applying a parallel transmission logic framework to a strictly serial USB question. It just doesn't work. Second, forgetting to check boundary conditions and edge cases. What happens when the buffer is totally full? Most students completely ignore this. Third, providing generic answers that aren't specific to the question context. To counteract these mistakes, you need to rely on the 3 rules of our complete answering system. Number 1, decode the command word precisely. Number 2, apply the Peel framework rigorously. And number 3, manage your time matrix so you don't accidentally spend 10 minutes writing an essay for a simple 2-mark definition.
I genuinely cannot stress this next point enough. The Principal Examiner Report explicitly states, the classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Guys, this is the ultimate examiner alert. If the paper describes a medical clinic trying to connect legacy ultrasound equipment to a modern PC and asks you to evaluate the use of VGA versus HDMI, you absolutely cannot just list the general specs of an HDMI cable. You will get 0 marks for that. You must talk about the medical clinic. You must talk about that specific legacy equipment. You must contextualize the visual clarity required for an ultrasound reading. Generic answers are the absolute enemy of the A-star.
To ensure you don't freeze up under the intense pressure of the exam room, here is a highly actionable memory hack. Create a custom acronym for the factors affecting USB, HDMI, and VGA ports. I like to use BRIP. That stands for Bandwidth, Range, Interference, Protocol, and Power. BRIP. Whenever you flip the page and see a peripheral port question, immediately write BRIP at the top of your page to instantly unlock your mental cheat sheet. It is a super simple structural framework, but it works like absolute magic to help you recall exactly what factors you need to evaluate.
Which brings me to our final provocative question. Are you ready to conquer time complexity, avoid those generic traps, and secure those top marks? The magic spell is entirely in your hands now. You've got the theoretical foundation, you've got the procedural framework, and most importantly, you have the examiner's mindset. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.